Okay, so we're gonna solve for the unknowns, and the unknowns are these four lovely x's. There's a lot of them in this one question. This is kind of getting you ready for rational functions, getting you used to manipulating them. So one of the things you can do here is start to think of the top and the bottom of fractions. Even though there's, they're binomials, there's two terms on each of them. There could be even three. Think of them as whole sections, okay? Like the denominator is an entire thing, the numerator is something. And with that being said, I could almost write it something like this. I could say A over B is equal to C over D. And the reason I'm just doing it this way is so that you can mentally think of the algebraic rules a lot easier, right? This is equivalent fractions. With equivalent fractions, we can just cross multiply and make things simpler, right? So I can take this entire x plus 6 and multiply it by the x minus 3, and the entire x minus 4 and multiply it by the x plus 2, right? And even if there's 3 terms, 4 terms, no matter what it is, I can move the entire top or bottom of something, which you already got here. So let's go into this. This is going to end up being, we'll have, so when I cross multiply, I move the x plus 6 over to the left side, and we have x minus 3 is still equal to the x plus 2, and in that same move we're going to move x minus 4 over here, so it's all multiplying. And this is that distributive property you would have learned a couple of years back, right? We do the first terms first, inside, outside, last. That's for FOIL or rainbow method, whatever it is. X times x gives us x squared, x times negative 3 gives us negative 3x, 6 times x is 6x, and 6 times negative 3 is negative 18. Yes. X times x is x squared, x times negative 4 is negative 4x, 2 times x is positive 2x, and 2 times 4 is negative 8. This is where we want to start collecting like terms. Since everything actually has to become equal to 0, I could potentially move everything from this side to the other side. But each of them is kind of like an individual move, where this would become a negative x squared. When I move this, it'll become positive 4x. When I move this to the other side, it'll become negative 2x. And when I move that, it's going to become positive 8. So I'm going to actually move everything in one shot, so everything's on one side. So I still have the originals, x squared. I'm going to try to pair them up with their like terms. We have negative x squared. We have negative 3x plus 6x, and we're going to have positive 4x and negative 2x. And I could have combined those before I moved them. It would have made that a little easier. And then we're going to have negative 18, and when I move the 8 over, it becomes plus 8. It's going to be our difference. And now there's nothing left on the right side of this equation. So we collect our like terms. X squared minus x squared, goodbye. Negative 3 plus 6 is positive 3, plus 4 is positive 7, minus 2 is 5x. And negative 18 plus 8 is negative 10. Now we just have to isolate for what one variable x. This makes this far simpler. We move 10 back to the other side. We get 5x is equal to positive 10. We divide both sides by 5. X is equal to 2.
Oh, see?